Hi folks, so what we're going to do here in this question is we're going to complete a question from the 2024 mock. It's from the exam craft paper, and it was B2 on the paper based on the oblique plane and intersecting planes, okay? So reading through the question here, it says the image on the right shows a modern sculpture with intersecting surfaces. You can see the image there. The 3D graphic below shows two of the surfaces ABE and ABCD. And then the horizontal and vertical coordinates for the surfaces ABE and ABCD are given below, and we're given the coordinates here. And what we have to do is basically reproduce this. So part A, draw the elevation and plan of the planes ABE and ABCD. Now, just before we start putting in the coordinates, what I often like to do just on this is I like to note, okay, so the first coordinate is the measurement in, okay, from whatever point you decide to start doing your measurements from. That's the measurement in along the XY line. And then this measurement is the measurement up, and this one is the measurement down to locate your points A, B, C, D, and E, and so on. Okay, so that's the very first part, and it's really handy marks to get for the elevation and plan, right? And that's what we're going to start by drawing. So, oh yeah, apologies. What I also like to do is I like to then note, you'll see here I've written numbers on the side, 1, 2, 3, 4, 5. I like to note which one is the lowest, so 55, then 60, and then we had 105, 110, and 135. So it saves me time. Rather than looking at each one, I can just mark them all in one go. So what I'm going to do is, starting off with an XY line roughly in the middle of my page, I'm going to pick somewhere about maybe here to start my drawing. Okay, and what I'm going to do is I'm going to measure in those coordinates. So reading number 1 is 55. So from that mark, I'm going to measure in 55. The next one then is 60. So keeping my set square steady, 60. The third one is 105. So 10.5 centimeters, or sorry, yeah, 10.5 centimeters. The next one is 110. So it's 11 centimeters. And then the last one is 135. Now you might look at this and go, well, all those coordinates are quite close to the left hand side of the page. That's what they've given me, so I'm going to trust then that obviously they'll all fit in the page afterwards. Now, from those coordinates, what I would do then is I would do vertical lines up and down. Because I'm going to have to locate those points. So I just find that the easiest way to do it. Okay, I find it a bit of a time saver. Now, starting with number 1, it's up 80, down 85. So I often measure 85 from the bottom. So starting with the very first one, 85 down, and up 80 will get me up to 165. And that there is point number E. So I would label that E. Okay, number 2 is number C. It's up 25, down 35. So the same process. I like to go 35 down to 0. 35 plus 25 will bring me up to 60. Okay, you want to be bang on your measurements here. And that number 2 is C. So there's C. On to number 3, in my case, up 10, down 95. So 95 down, put the third one in. Hang on. And up 10. There we go. That's the third one, so that is D. And there's D. And then we're on to number 4, which is up 95, down 15. So up 95, so I'm going to do 10 up to 19.5. Visualizer just slightly in the way here. Hang on. And it's down 15. So 10, 15 down. Okay, and that was number 4, so that's B. And there's B. And finally, the last one is number 5, A. So it's up 50, down 85. So 85 down to 0. And up 50, 10, 20, 30, 40, 50. And that is A. Right. Now, looking at this to see how we should heavy it in, you can see when we're looking into this direction at the elevation, I can clearly see A. Because that's kind of at the front. I can see E, it's out on its own, and B is the highest point, so I can see the ABE surface. So that can go in completely heavy in the elevation. Okay, sorry, I'll zoom out there. I can heavy that in completely in the elevation. So heavying that in. Okay, likewise, I can also have it in the plan view because B is kind of hiding or is covering over the other parts of it. I can see A and I can see E. So I can see both of those in both the elevation and the plan. And now I have to focus on the surface A, B, C, D. So A to D, A to C, I'll see in the elevation. C to B, I may not see when I'm looking in this direction at it, okay, as it's projected onto the vertical plane there. All right, so A to B is already heavied in. I'll now heavy in A to D, D to C, and finally C to B. Now, I'll put this line in lightly first, heavy in this portion, then hidden detail. Because that surface A, B, C, D, as I look in this direction, I cannot fully see the line from C to B. As you can see, there's a part of it that is in hidden detail. Now, I have to do the same thing in my plan. A to B is connected, okay, and now I'm going to connect, oh my God, did I make a mistake? It's A, B, E. I made an absolute doozy there. Apologies, guys. So I should have connected this one, A to B to E. I'm going to have to rub out a line there. Apologies. And then I will connect A to B, B to C, C to D, D back to A. I'll rub out a line here in a second. My absolute apologies there. And then C to D. So that line would connect to there, and I would have hidden detail under it there. And just take out over here. And it was A, B, E, not A, B, C. So that line there is the line that I should not have put in. Apologies there. Go over that in the rubber. Okay, I'll just re-go over that bit there. Right, and that's what I should have done. Apologies for that. Now, at this point, that there is the elevation and plan done, so I'd often just tick it off. Okay, that's part A done of the question. Draw the elevation and plan of the coordinates. And what I often like to do then at this point is I do like to put in just my XY line directly underneath it. I think it just splits the views nicely and it looks good on our page. Now, I would encourage this. It doesn't have to be done, but I would encourage this. They've used colours here to, I suppose, denote the difference between the plane surfaces ABE and ABCD. So I'm going to use colours as well. So like they've done with a red here, I'm going to shade mine in red. So by all means, kind of skip ahead in the video until I have these kind of coloured in. So I'm going to go with the red here because I can see that surface. I'm going to shade that in as best I can. Just continue shading it in there. Now this can be done at the end of the question if you want, because it just shows you as a student, it shows your understanding of the problem. Okay, that's my one triangular plane surface. So we've got the triangular plane surface there. There's the one in elevation. Now I'll do the one in plan. So same concept, I'm just going over the edges. So ABE is in red. I find it would help with your understanding. Okay, so there's that one, and I'm going to go with the yellow for the other one then. I'll do this one up here first, take a little bit longer. Okay, there's the yellow surface done in elevation. Now in the plan view, I'd only see this much of it down here, along with this much of it here. Right, So I just find using a little bit of colour will help us kind of figure out the question a little bit better as we work along it. So there's the first part of the question done. Now what we're going to do is, it says here, we want to determine the dihedral angle between the planes ABE and ABCD. Okay, so anytime you're getting a dihedral angle, what you need to do is you need to see the two surfaces as edge views. Essentially, you want to see them as lines. And most importantly then, we also have to find the common line between them. In this case, the common line between the two surfaces is AB. Now, the only way we can get the dihedral angle is by first of all finding the true length of this line and then looking along that true length so we see it as a point view. So, first of all, AB, I have it here in elevation, I have it here in the plan. Is either one of those a true length at the moment? No, because neither line is parallel with the XY line. Okay, neither line is parallel with the XY line. Therefore, I have to find that line as a true length. Now, I find the easiest way to do this is project an auxiliary view, and I'm going to do that from the plan. I'm going to project an auxiliary elevation. So, what we're going to do is the common line between them. I'll put that line in a bit heavier here. Okay, and likewise up here, I'll do the exact same. Just to note that that's the common line. Now, with that being the common line, I want to look perpendicular to it to see the true length of it. So I have to set up, if I'm looking perpendicular to it, an auxiliary view, an x1, y1. So, parallel to AB, I'm going to project out like this. That there is going to be my x1, y1, and all my points then will project out perpendicular to that. So A projects out, D, E, B and C. Out along there. Now, if you project from the plan, you take your heights from the elevation. I'm going to work from A backwards. There's A. Take that height there. And then I'm going to come down to here. Mark it out. That point right there on the outside, those lines are very close. That is A1. Now I'm going to work on, I want to B next. There's the height for B. Find B here. Mark it up. Marked it out there. So I've now found B1. I'm on to D. So there's the height for D. Find where D is. It's down here. There is D1. Find C. And there will be C1. And then finally E is the last one. And out to E here. Mark from the X1, Y1. And there's E. Okay, now likewise, I'm just going to connect up the same surfaces. So A and B are the common line. That's the line of intersection between the two surfaces. But what's important about this line now is because I looked perpendicular to that line, which was here in the plan view, this line now is a true length. So, heavy in that, heavy in this. And then A connects to D, D to C, and C to B. Okay, so that there now is our true length. So I'm going to write the letters TL on that. And once again, we're going to heavy in our surfaces in the colours. So starting with ABE, I'm going to just go over this and I'll do it as quickly as I can. So by all means, you can skip ahead in the video until you get to the point where I'm finished doing the colouring. There's that one. Okay, so there we have it. There's the two surfaces once again coloured in, but what's most important about this now is that we have the true length of the line AB, which is the line of intersection. Now, what we can do is we're going to look along that true length to see the line AB as a point view. And what's helpful then is any line that is, we look along it when it's a true length, and if it's on a surface, we will then see those surfaces as edge views. Therefore, we're able to get the dihedral angle between them. So what we have to do is we have to set up now an x2, y2 perpendicular to the true length line. Because we're going looking along the true length, so we have to set up an x2, y2 perpendicular. So I'm going to set it up here, rotate my set square, and that there now is our x2, y2. And we'll project out all the points perpendicular to the x2, y2. Or I could also say parallel to the true length line. And then there's D, and likewise with C. You can see some of these are a bit short, so once you get the line drawn, make sure you're accurate, extend, will be 100% on the money, and extend. Okay, now rule of thumb here is, what you're always going to do is, we've projected from the x1, y1 view. Now what I'm going to do is I'm taking my distances from the previous xy line back, so that's the x1, y1 back to the plan. So first one I'm going to take is the distance from the x1, y1 back to B. Now what you'll notice about that distance is that distance there is the same as the distance from the x1, y1 back to A. So then when I mark them out here, what's helpful then is I'll see the points A and B in one position right here, which is called a point view, but I'm going to call it A2, B2. Okay, just zoom in there a little bit so we can see it a bit better. Now what I'm going to do is I'm going to take the distances back for all the other points. I'll start with E, and I'll mark it out from E1. Up there is now E2. And then I'm going to mark it for C. And then mark out from C1. There is C2. And finally, D. Now this one here, we'll get onto this one in a second. Now it should be up there. Now, what I'm going to do is I'm going to connect the surface ABE, which I'm now going to see, because AB is a point, I'm going to see that surface as a line. Okay, and what I will do is I'm just going to go over that line in red, because that's the color of my surface. Okay, now what I'm going to do then is I'm going to connect AB to C. Now if we're accurate, and it should be accurate, when I connect these up, when it goes through this point here, or when it connects up with C, it should go through this point for D as well. Now sometimes as you work through these questions, accuracy can be a challenge, but we'll just see what mine is looking like. Yep, and it has worked out there, so I'm quite happy with that. Okay, and that point there is D2. Now what I would often do is I would take the one that's the furthest away, in this case it was C, because D was slightly closer to the x1, y1. I would mark the C and then just connect the C back to AB, and where it passes through the D1, technically that should be D2. Okay, so there we have it, and once again I'm going to put that in, this time in yellow. And what we're seeing, and what's helpful here is, we're now seeing those surfaces ABCD and ABE as edge views. We're seeing them as lines, okay? And the angle between them, that there, put a little symbol here, that is the dihedral angle. And usually, you would get your protractor, just try and locate my protractor here, apologies. There it is. Usually you would get your protractor. Now I'm after going over mine in colour. Probably a bad idea, I should have measured this first. But I'll put it on the line. One line, and I'm going to measure from that line. And mine there now is saying from 0 all the way around, it's saying 50, I'm going to say 56 degrees. That is my dihedral angle. Okay, usually in an exam they'll give you kind of like a little discretionary, so as long as you're within a certain range you'll get the marks. Okay, so obviously you can see the importance of being accurate. Now that's the second part of the question. The third part, find the true shape of the plane ABE. So this plane here, ABE, which is the red one, we want to find the true shape of that surface. So the easiest way we can find it as a true shape is by first of all seeing it as an edge view and looking perpendicular to that edge view. Have we got an edge view of the plane ABE? Yes, we do. This line here, technically ABE, when we see the surface as an edge view, we see it as a line. Now, if I technically look in this direction at it, okay, and set up an x3, y3 in this case, I'm looking perpendicular, but when you look perpendicular to something, you see its true shape. So, or a surface, not something, I should say. When we look perpendicular to a surface, you will see its true shape. So I'm going to set up another auxiliary view. In this case, it's an x3, y3. I'm going to set it up perpendicular, like that. And then I'm going to project out the points AB, or in this case A2, B2. And I'll also project out, so I have to move my set square here a little bit. Oh, slipped. Right there. And from E2, project that out. Now this line here is now called an x3, y3. But the normal rules will just apply. Like we did up here, where we took the distances from the x, y1 back. Now here, we were in the x2, y2, and we're getting the third one. We'll take the distances from the x2, y2 back. So, if I want to find A, I'll mark the distance from the x2, y2 down to A, and then find A, and from the x3, y3 line, mark it out. Likewise, I'm going to do the same with E. It's just the next one down for me. Go up to E here, mark it out, and likewise with B. It's quite small here, so just have to be, there we go, and mark it out. Okay, I'm going to mark those. So this one here is A3, then I had E3 and B3. And all I'm going to do then is heavy in that line. Okay, and what I've now found there is the true shape of A, B, E. And rather than colouring in the whole thing again, I'm just going to very lightly heavy in the outline. Okay, just to denote the colour of it again. Right, so there's our true shape, and that's the third part of the question done. Now that part of it was probably very much dictated by you finding the dihedral angle here. Okay, so the last part of the question, determine the horizontal and vertical traces of the plane ABCD. So you'll see here we've got a plane ABCD, which is the yellow surface. Now this is a little bit tricky, and it's all to do with the oblique plane, okay, and your understanding of how to find traces in relation to this. So a trace, okay, is where that surface technically would intersect with the horizontal plane. So if you imagine ABCD is technically floating in midair up here, but essentially I want to find where, if it was to be extended down, where it would intersect with the horizontal plane. Okay, now if you imagine BC was to come down all the way down here, and at some point it will pass through the horizontal plane. Likewise, AD, if that was to extend down, and at some point it will pass through the horizontal plane. Once I have 2 points, I can then technically draw in my horizontal trace. And it's very easy then after that to find our vertical trace once we have the horizontal one. So that's the method we're going to kind of use, that little principle there. So how do we do that? So in elevation, what we're going to do, we'll do it in both views, but in elevation, I'm going to extend down BC until it hits the XY line. And you'll see by extending it down, it hits the XY line right here. Technically, that is the point where it actually hits the ground, the horizontal plane. So how do I actually locate that then in my plan view? So what I'm going to do is I'm going to bring that down, and somewhere along that line, as I projected it down, somewhere along there is that point on the horizontal trace. So, like I did in elevation by extending it down, I'll do the exact same thing in the plan. BC just needs to extend out. And where it extends out and passes through this line here, that gives me a point right there that is on my horizontal trace. Now, that's one edge BC. I can also use it for the edge AD. I could technically use it for the edge CD, and I could use it for BA, but AD is the more appropriate one here based on my drawing. So I'm going to extend it down. Once again, this point here is a point in reality where it hits on the horizontal plane. So where it hits on the horizontal plane, it has to be down here somewhere in the plan. So somewhere along that line there. The edge I extended was AD, so I'll do the exact same here. I'm going to extend out AD, and it passes through right there. Now, I have 2 points on my horizontal trace. All I'm going to do now is join those together. That is where it passes through and it meets the XY line right there. So that there is my HT. Okay, I have found my horizontal trace. At this point, I will actually extend out my XY line. Okay, just out to there. And now what I need to find is my vertical trace. Once you have one trace, it's very easy to find the other. Okay, so the point I'm going to use here, I'll use the A point. So to find it, I'm going to go parallel to the horizontal trace. So setting up your set squares parallel to the horizontal trace. Move it up as far as the A. Where it hits the XY line, right here, I'm going to now project that upwards, because that's technically where it's on the vertical plane. And then from A, project across. And you'll see there, by going parallel to the horizontal trace until it hit the XY line, projecting it upwards, because that's where it's hitting on the vertical plane. So that has to go up and bring A across. Right there is now a point on the vertical trace. And because I have one point on the vertical trace and I know where it's hitting down here for the horizontal trace, I can extend those, join them together. And what I've now found there is the VTH. Okay, that there is the fourth part of this question. Determine the horizontal and vertical traces of the plane ABCD. Okay, quite a nice question there, guys. Little bit just of understanding of intersecting planes, dihedral angles, true shapes of surfaces. Okay, looking perpendicular, and then the VTH at the very, very end. All right, that's the question then done there, guys, from the 2024 exam craft mock. Hope you found it helpful. All right.